Okay, so in part 3 of our lab, we're going to be looking at this electrophorus that I've designed using a pie tin and a styrofoam cup, and there is a small light bulb attached as well. You can see that one of the wires is on the surface of the pie tin and the other one is not. It's out here kind of floating in space. And I've placed this on top of a styrofoam plate, which we'll get to see in a moment. So the first thing we're going to do is charge the styrofoam using this fur, and then kind of play around with our electrophorus and see what's going on. Okay, so I'm going to be charging the surface of the styrofoam using the fur. And this again is triboelectric charging. It's through friction. Okay. And for this first one here, I'm going to be replacing the pie tin onto the styrofoam. All right. So what happens when I touch the edge of the light? I think we caught that on camera. Okay, so if you couldn't see, the light bulb flickered on for just a second and it lit up. I could also hear that there was a bit of that crackly kind of static electricity sound that we're really used to hearing. So that was kind of the auditory part of the experience, as well as that visual of it lighting up. And next thing we're going to do is basically the same again. I'm going to charge this, but instead of placing the pie tin on the styrofoam, I'm going to hold it about 1 inch away. Okay, so I don't know if you could see on camera, but our little light did light up and flicker, and there is about 1 inch of space underneath the pie tin here, so it's not actually making contact with the surface. Okay, so let's talk about what we saw with the electrophorus and why the light turned on. So ultimately what's happening is when I'm rubbing the fur on the styrofoam, I'm creating an electric charge through triboelectric charging. The styrofoam actually has a higher electron affinity than fur does, which simply means that it keeps more of the electrons, giving it a negative charge. So we have a negatively charged styrofoam surface. And then I'm going to introduce the pie tin, which is a conducting material. It's metal, so it's more of a conducting material. And so as the negative charge comes into contact with my pie tin surface, the bottom side of the pie tin is going to, the negative charge of the styrofoam is going to be attracting the protons, the positive charge from the conductor. So the bottom surface is going to end up being a positive charge because it's attracted to the negative electron charge on the styrofoam. The upper surface then is going to become negatively charged, and that's because through induction, kind of an induction charging process, right, it polarizes the protons from the electrons. So the bottom surface is going to become positively charged as it attracts here, and then the top surface will be negatively charged because the electrons are kind of polarizing and being pushed to the opposite side of the conducting material. So now that our surface has a negative charge, that's the same as what this little light's going to end up happening. It's going to want to kind of create a flow of electric charge through the system through its little wires. When I touched it with my finger, I provided the ground. And so that by grounding this little wire, it actually allowed the flow of electrons to pass through the little light bulb, heat the little filament inside, and cause it to light up. Now, why did it work when the pie tin was held about 1 inch above the styrofoam surface? That's because the electric charge on the styrofoam was strong enough to charge the pie tin through induction. So that is a process, again, that doesn't require any contact. And so even through a small space, there was enough charge to still charge the pie tin. And that also kind of comes from like the point charge equation that we have, where the charge attraction between two particles is inversely proportional to the distance between them squared. And so we're going to see in a moment that when I actually hold the python like a foot or 2 feet above the surface, that distance is now too far and the electrical charge is not strong enough to actually be like impacting or interacting with the python, and so we're going to see that the light bulb does not actually turn on. Spoiler alert. Okay, let's take a look at that. Okay, so I'm going to be charging the surface of the styrofoam. Again, it's going to have a negative electric charge just because it has a higher electron affinity than the first. Okay, this should be enough. So I'm holding the python about a foot above here, and now I'm going to try and touch the light and see if it'll light up. You can't see it on the video, but it did not. So it did not actually light up, but I will show and kind of confirm here that it would still work if I were closer. Okay, the lights are on again, so you probably couldn't see it in the video, but I could hear it. I could see a little bit of lighting up. So as I reduced that distance, the electrical field from the styrofoam surface was strong enough and interacting strongly enough with this conducting material that it did allow me to light up the little light bulb, and then I could also kind of hear that electric current going through. Okay, for this next demonstration, I am standing directly in my kitchen and right next to my stove, which I'm going to end up using as my ground because it is metal and it is touching the ground. So what we're going to do first is charge our styrofoam plate, triboelectric effect. Here we go. Okay, I will carefully place the conducting plate onto that surface. I'm grounding myself on the oven and then touching the metal surface. And then I'm going to hover over these little pieces of paper that I have. So I don't know, yeah, you can see that. So it's having this really cool attracting effect with the paper. It's causing it to kind of like bounce up and stick to the bottom of the pan. Okay, let's talk about why. Okay, so let's talk about why we saw the paper attract to the bottom of the python. So ultimately what was happening is I introduced a charge to the styrofoam plate, the styrofoam base, through the triboelectric charging. As stated before, it'll be a negative charge. So putting the plate on here causes the charges within the plate, which started at a neutral charge, it causes the protons and electrons to polarize. And we talked about how the protons would be polarized to the bottom surface, attracted to the electrons from the negative charge here. And then the electrons would polarize up to the top surface. So when I had this charge and then I touched this and grounded it, what actually happened is the excess electrons had a place to flow out of the system, because now we have electrons on the styrofoam, which are polarizing everything going on in the plate. And then I have electrons kind of gathering on this top surface as well, and there's this repelling force ultimately from the electrons on the styrofoam. So when I'm touching it while grounding, it allows the entire system here to come to a neutral charge. It dispels the excess electrons through the ground. So now when I separate these two bodies, I have two separate systems. And this system here is now positively charged because it discharged all of the excess electrons, and then I picked it up, and so now it actually contains more protons than electrons in the system. So now it has a positive charge itself. As I hover it over the paper, it actually still has a residual charge. So as I hovered over the paper with my positive charge due to the protons, it's polarizing the paper as well. So paper is neutrally charged, and so as I'm hovering over with a positive charge, it is attracting the electrons to the surface closest, and then that creates this opposites attract effect, and so now it's actually just being attracted to the bottom of the python. So that's kind of what's going on there. That attraction is through induction again, because as I'm hovering, I'm not actually touching the pieces of paper, so it's causing that polarization process again, and it's attraction, or it's charging through induction, and so that's kind of what's happening between the two. Okay, so I've reset our lab conditions back to how things were at the end of step 6, and so now we're going to take a look at step 7. So step 7 is telling us to kind of repeat step 6 in terms of putting this thing back down on the styrofoam plate, holding it ground. Let's touch this again, and then see what happens when we hover over paper. Okay, it is still attracting the paper. I'm going to replace this and now attempt to repeat steps 3 and 4. So step 3 was to touch the ground on the light and see if it'll light up. I'm going to turn off my other light so you can see this. Okay, so now the lights are off, it's a little bit eerie, but we're going to attempt to repeat steps 3 and 4. So step 3 was to ground ourselves and then touch the wire and see if it'll light up. Ooh, you could really see it that time. And then step 4 was to lift this about an inch or so above and then touch the grounding wire as well. I'm not even touching, I'm just hovering near it, and it's actually lighting up pretty well. Okay. All right, I'm going to turn the lights back on and we'll talk about why. Okay, so the reason that we were able to repeat steps 3 and 4 and even step 6 with the hovering paper and just kind of keep returning the plate to the styrofoam surface and having these effects be reproducible, the reason that all of those things could kind of happen indefinitely is really because the styrofoam is an insulator. So what that ultimately means is that insulators want to hold on to their electrons. They don't readily move them around. They have more rigid atomic structures with their electrons. So when I was charging with the fur, remember that the styrofoam had a higher electron affinity. And so that means even though it doesn't want to receive electrons, it's an insulator, it still has a higher affinity for those electrons. And this is also an insulator. It doesn't want them either. But between the two of them, somebody's got to take them, right? And so it ended up being the styrofoam. So now the styrofoam is carrying more electrons than it naturally would, maybe at a neutral charge type space where it would exist in the wild. And so now those electrons are in that insulating material, and they're not readily going to go anywhere. So the styrofoam is what ends up being kind of this source of charge repeatedly. And so as we allow this conductor to interact with the insulating material, it keeps receiving this charge from the insulator through those electrons. So that's why we're able to kind of keep playing with the electrons.